PowerPoint back. There we go. Oh, you know what though? Well, that's right. Okay. So a series is a sum of terms, and we're adding them all up. The dot, dot, dot is significant because that shows we keep going forever. Okay, for notation. All right, two basic questions that come up about series. First question is, just like we did with a sequence, does my clicker not work when I'm recording? Look what you did to me. Does it converge or diverge? Okay, so that's going to be one question that we answer. And what do you think it means for a series to converge or diverge? I'm not saying how do you determine, but if you're adding up numbers, what does it mean that it converges? That means it converges to a specific answer, meaning is there a specific sum for adding all these numbers up? How could you get a finite answer if you keep adding up an infinite number of terms? Remember we talked about if the terms start getting so small that eventually you're adding 0, then you could say, hey, I have a finite sum. So converge means it'll add up to be a finite sum. Diverge means no, it just keeps growing and growing. I can't cut it off. Okay? And then the second question is, what is the sum? So if it converges, what is the sum? If it's a diverge, then they wouldn't ask you what the sum is. Okay? So now we begin our trek through Unit 9, and basically there are 10 tests that they say that you have to know for the AP exam to determine if a series converges or diverges. We are going to talk through 9 of them, because one of them I haven't seen show up in 30 however many years. Remember the telescoping one? Was that? Did we talk about last time? Did I mention that? Okay, that was going to be today. Never mind. So there's one that I've never seen show up in 30 years of teaching this. So you know what? We're going to be like, yeah, I don't think it's going to show up. Just so for time, we'll go right through that one. All right. So our first test is called the nth term test. Okay? The nth term test is only used to determine divergence. It doesn't tell you for sure if something converges, but you can determine if something for sure diverges, meaning if there is no sum. So what did we just say? If the terms keep accumulating stuff, then we can't give you a finite sum, right? We said if the terms are getting so small that eventually you're adding nothing, then you can't have a finite sum. So what would make you decide if a series actually diverges? If the limit, what? As n approaches infinity, basically is not 0. Because if the limit is 0, eventually you're adding 0, correct? If the limit is not 0, then you're adding more than 0, so you can't give a finite sum. Does that kind of make sense? So the way we write that is, we say, if the limit as n approaches infinity of your term, of your series term, meaning just that, formulaic term, if that limit is 0, if that limit is not 0, that means you're adding more than just 0, then we would say that the series diverges. So if that limit is not 0, so that means, like, say if the limit is 1, that means eventually you get to the point where you're like adding 1 every time. Well, you're not going to have a finite sum. Does that kind of make sense? So if the limit is not 0, then we know the series diverges. And this works a lot. This should be your first thing you should always check for, because this can be like an automatic, I'm done. If that doesn't work, then we go on to something else. So what would it mean if it doesn't work? Well, what if it does converge to 0? In other words, what if the limit does equal 0? Well, then we say that the test is inconclusive. So if it does equal 0, that doesn't mean it converges. Just because the terms go to 0 doesn't mean they go to 0 fast enough. They have to go to 0 fast enough to be like we're adding nothing. Okay, and that's why we started talking about how fast do certain things increase. That's kind of the thinking where we're heading. Okay, so just because it equals 0 doesn't mean it's a converge. It means it's inconclusive. So if the limit equals 0, then the series might converge or diverge. We don't know. We can't tell. It might still diverge. We just have to try another test to prove it. So that's why we always try this one first to see if there's a quick diverge, and then we're done. If the limit does equal 0, then we might go try something else. Well, we would have to go try something else, unless we just wanted to quit and crawl under the table. Okay? Nth term test. And now we practice, yes? So, converge or diverge. The first example you have there, the n squared over 2n squared plus 3n. So what are we going to do? We're going to try the nth term test. We're going to take the what? The limit as n approaches infinity. Now, I don't necessarily care, like when you're just thinking out loud, I don't care that you actually, write that out, but I want you to know that we're doing the limit, okay? I want you to know you're doing the limit, the nth term test. Well, what does that limit equal? 1/2, everybody agree? So that is not 0, right? So converge or diverge? It's a diverge. You got to be careful because it's kind of not the same as what we did with sequence, right? If this had been a sequence and we got 1/2, we would say converge, right? But since it's a series, it's a diverge. Everybody with me? What about the next one? What's the limit as n approaches infinity of that one? Isn't it just 2 to the infinity, which is infinity? That's not 0, so therefore it's a diverge. So it doesn't matter if it's a constant or if it's infinity. If it's not 0, it's a diverge. Okay? What about the third one? What's the limit on that one? 0. Oh, so is it converge then? No, it means it's inconclusive. We don't know. We have to try something else. What's your speculation? Because think about 1 over n. So if I start with n equals 1, I would have 1 over 1. And then if n equals 2, I'd have 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over n. Do you think that's going to converge to a specific sum? They're definitely going to 0, right? Do you think that's going to converge to a specific sum where we can say, hey, eventually it's going to level off at this sum? What's your guess?
Is this one of the ones where pi shows up randomly?
No. I don't think so. What's your guess? You think it's going to go fast enough? This is just a guess. We're not going to find out till the end of class today. You say yes. You do. You think this is going to converge and have a specific finite sum? Okay. Y'all agree with Sydney? Do you disagree with Sydney?
I think it will be like a number less than 5.
So you're saying it will converge to a specific number, but it's going to be a relatively low number. We'll see. All right. So what if I have an inconclusive? I need some more tests. I'm glad we need more tests. Guess what? I got 9 more, and I'm going to share 8 of them with you. Not all today. We're only going to do a total of 1, 2, 3, 4 of them today. Okay, we just did 1. Here comes the second one, geometric. You remember talking about geometric series anywhere at all in your class? If you did SAT prep, you might have done this. Anybody do that?
I remember the word, yeah.
Okay. So what is a geometric series? Anybody know?
Isn't that where you keep increasing by like the same multiple?
Exactly. You keep increasing by the same multiple. So it's like each additional term is the previous term times some specific number. So maybe you multiply by 5 every time to get the next term, or maybe you multiply by 1/2 every time to get the next term. Each additional term equals the previous term times some specific constant. That's a geometric series. Now, I don't know that SAT specifically uses the phrase geometric. I don't know if they make you know the name of it, but I know they have you look for patterns. So like, for example, if I had 1 plus 3 plus 9 plus 27 plus, what would the next one be? Huh? What would the next term be?
Wouldn't it be whatever 27 times 3 is?
Wouldn't it be whatever 27 times 3 is, which is 81? So do you recognize that you're multiplying by 3 every time? So whatever you start with is generic, and then we multiply by 3 every time to get the next term. So that's what a geometric series looks like. And you'll notice the notation that we have. Did I write that down for you? So the way we would read that is we'd say the sum as n goes from 0 to infinity. The a represents the first term. The a represents the first term of the series, because think about it. If I plug in a 0, that's my first term, right? If I plug in a 0, wouldn't I have r to the 0, which is like 1? So do you see how a is the first term, or if you want to call it the 0th term, right? And then r is what we call our constant multiple. So that's like on the previous one, the a would be 1, and the r would be 3. So that previous one, which I didn't write on here, but if I were going to write a series notation for the example up there, I would say the series as n goes from 0 to infinity, a is my 1 times 3 to the n. And no, you don't have to actually write that, but that's how I would write the series for what I started writing all those terms for. Jordan, you made a face. You okay?
Yeah.
Gotcha. So get used to this face is what you're saying. Okay. All right? So if that ratio number, if the number you multiply by, if the absolute value is less than 1, meaning I don't care about positive or negative. Okay, so if the absolute value is less than 1, so that means if it's like a fraction less than 1, if it's 1/2, 1/3, 1/4, 2/3, 3/4, right? If that ratio is less than 1, then it's a converge. Because what that means is, think about it, if you multiply by some number less than 1, aren't your terms getting smaller? And so this is saying, hey, they're getting smaller fast enough that eventually they're going to 0, and we're going to say there is definitely a finite sum. So you know what the next one's going to be. If you multiply by some number that's more than 1, even if you multiply by 4/3, I know that's a fraction, but it's a fraction more than 1, right? Again, doesn't matter if it's positive or negative, then it's a diverge. Because if you multiply by a number more than 1, aren't the terms growing, right? So if it's geometric, these are my favorite because it's so easy to tell if it's a converge or diverge, right? Whatever you're multiplying by, boom, you know if it's a converge or diverge. So that means, well, what if it does converge? We need to know how to find the sum. And by the way, whenever you get to a problem on the AP exam that says find the sum of the series, it's usually always geometric because this is the one specific, nice, neat sum formula we have. Most of them, we don't have a nice, neat sum formula. So usually this is one of the only ones they'll ask about. Okay? Formula for the sum is a over 1 minus r. Assuming the series starts at 0, like our initial setup was, then it's a, so it's that first term over 1 minus the ratio. Okay? And so we go to our examples. That's test number 2. First example. Do you see the nice, neat format? You see the a, you see the r to the n, so you know it's geometric. So is it a converge or diverge? Well, what is r? 3/4, which is definitely less than 1. I'm not saying you have to write out less than 1. This is just us talking about how I'm making my decision. On a free response, if you were going to say, hey, this converges by the geometric test, that would be a great way to write it. That you can see that the ratio is 3/4. You know it's less than 1. That's showing that you know the geometric test. So therefore, converge or diverge? Converge. Oh, if it's a converge, then I need to find the sum. So what's the a part of that formula? 2 over 1 minus r. Oh, you mean we got to do some math and without a calculator? What is 2 over 1/4? Don't hurt yourself. Isn't that just 8?
No.
1 minus 3/4 is 1/4. Is that what you're talking about?
Oh, yes. Thank you.
Everybody okay? Dividing by 1/4 is the same as multiplying by 4, right? Or you can do that outer over inner, you guys that are my algebra people.
I drew it.
Okay? 4, 8. So the sum is 8. Great. Geometric is the most straightforward finding the sum. You're making a face at me. What's wrong? Oh, okay. Everybody okay with that? It seems so innocent and harmless, doesn't it?
No.
What? You don't think that does?
You have to remember it.
Well, yeah, hello, you're here. Okay, let's try this one. Whoa, wait a minute. Is that geometric? Is that a times r to the n? Well, what if we do this? Okay, so I can't use that unless I know it's geometric. And how do I know if it's geometric? I need an a times r to the n. So what if I think of it like this? 2 to the n plus 1. Doesn't that mean it's like a 2 times a 2 to the n? Sorry that it's kind of on the bar. Right? Because if I have 2 times 2 to the n, when I'm multiplying the same base, don't I add my exponents? So we're okay with that now? Hey, if I have a 2 to the n over a 3 to the n, could I combine those and just say 2/3 to the n? So I'm saying leave that 2 that's out in front there, and the 2 to the n over 3 to the n, can you just write 2/3 to the n? I'm just manipulating, right? I mean, this ought to be right up your alley. You guys are master manipulators, right? Everybody okay? So if I write it like this, is it geometric? Check. Okay, so converge or diverge? Converge, because of the 2/3. So if it's a converge, that means I can find the sum. Try it. See what you get for your sum. So if you can get it in the nice, neat format, you got your formula and you're there. Is this feeling any more harmless yet? So the difficulty that could come in a geometric type is if maybe it doesn't look like geometric, and so you have to kind of manipulate it to get there. But I promise you, basically every day when we learn new tests, we're going to be practicing all of the tests. So it's like, yeah, today we're doing 4 tests. The next day we're going to do 2 more tests, but we're going to be practicing 6 of them. The next day we're going to do 2 more, but we're going to be practicing 8 of them. Okay? Everybody good? All right. What about this one? Is it geometric? It's okay for r to be negative, right? What's the a out in front? A 1. No problem. Geometric. Is the absolute value of r less than 1? Remember, we don't care if it's negative. So this converge or diverge? Converge. Now, we don't care if it's negative when we determine converge or diverge, but the r is still a negative 1/2. So when we go to find the sum, remember, r is negative 1/2. Okay? So set up your sum, a over 1 minus r. This one still gets me all the time. I always have to check myself. Can we agree on the 2/3? Here's what gets me. Remember when we first wrote what a geometric series looks like? Remember the a times r? It was the sum as n goes from what to infinity? 0 to infinity, right? And that sum formula is if you start with 0 and go to infinity. But this one says to start at 1 and go to infinity. You with me? It's okay. So when I did this is including the 0 term, this formula. So, but I don't want to include the 0 term, do I? I want to start at the 1 term. So I just need to remember to subtract out the 0 term. So what was the first term? The A number? 1. So I need to subtract out. I need to subtract out the 0 term, so I need to subtract out 1. And the sum is actually negative 1/3. So if your counter over there doesn't start at 0, you need to remember that formula that I gave you for the sum, that includes the 0 term. And it seems like inevitably there's one of those that shows up, like in a multiple choice especially. You just got to keep an eye on that. Don't worry, you'll get burned by it and then you'll be fine. You won't forget. Maybe we can get you to be burned by it like on a online quiz or something. The first trial. And then the second trial you'll realize, oh, dang it, that's what she said I was going to miss, and then you won't miss it ever after that. Right, Kathy? Yes.
Is it always -1?
Well, it's whatever the A is. So remember, the A is the number out in front right here. So if there had been like a 2 out here, you would subtract the 2. It's whatever the number is out in front, that's your A. Because that's the quote 0 term. If you're not sure, you could always just plug in 0 for n and see what that equals. Okay? Geometric? Gonna wind it up? Or are we? What about this one? Is it geometric? Basically, you can kind of see, anytime you have numbers to the weird ends, we can probably manipulate it into geometric. So let's picture. How could I separate that 3 to the 1 minus n? 3 to the what times 3 to the what? Couldn't I do like 3 to the first times 3 to the negative n? Could I do the same thing on the bottom? Okay, let's do that. So if it's multiplication, how are we going to combine things? What do you want to call the A? That 3 over 4 that's out in front there. And then I actually have 3 over 4 to the what? To the negative n? Sorry. But if they're to the negative n, since we want positive n, couldn't I flip them? You know the whole negative exponent deal? I'm not saying you have to go in this order. Like you might have done 3 over 4 quantity to the negative n and then flipped, whatever order you want to go into. But in order for it to be geometric, we need a positive n. Everybody good?
And when you rewrite it, do you need to include the sigma and everything?
I mean, since a lot of times it's multiple choice, who cares? Right? And if you write it, it's kind of like the other stuff. If you write it one time and then you're kind of doing kind of scratch work but still legible, you're probably okay. Yeah. Pardon me?
So free response should be fine.
Free response on this isn't as picky because probably what they would rather hear you say is something like diverges by geometric test, by geometric series test, as opposed to showing all the stuff, something like that. So that's why you're going to always hear me keep using the name. So converge, diverge. Diverge because the R is the 4/3 and therefore the sum. We don't care. There is no sum, right? If it diverges. All right. So telescoping, that's one of the tests that I said, we're not doing that one. It's a shame. It's kind of fun, but you know, if you feel like you've missed something after the AP exam, we can kind of come back together and do that if you want to. All right. We're not done today. That's 2 tests. We have 2 more. Okay. But I want to show you, if you look at your next page where I have the things, the snips there, and at the top I think I have the numbers. But do I have the same numbers as what I have up here? Because I think I crossed some out. Like,
Yeah, we have one.
yeah, if it's not up here, cross it out. Because some of them were telescoping. Because last year, this is the first year I'm not doing it. Finally, I'm like, well, this is dumb. It's never on there, and if I really have to cut time, that's what I'm going to cut. So I want to show you how we really need to kind of write our answers to these. Notice I put on there, identify which test you use. Okay, ready? All right, so, hey, you're supposed to come down. Hey, stop. There we go. Sorry. So look at number 9. Look at it on your paper since mine wants to be blurry for a while. When you look at number 9, converge or diverge? Does everybody agree? Converge or diverge, number 9? Diverge. How do you know that? Because it's the geometric series. So if you can just write diverge, maybe just put a G for geometric. So we have to start remembering the names. They're getting more and more picky about making sure you know the names. Okay? So don't go crazy showing a bunch of work. Don't show a bunch of big long involved stuff. Just say diverge, G for geometric, just so we know. Okay? So what about number 11? Diverge because of why? Geometric. So see if you can do those odd ones. Is 13 geometric? It's not. We only know one other test. The nth term test. Does the limit equal 0? No, so it must be. So on that one, maybe just say, like nth term test, or I don't know, NTT or something. Diverge by nth term test. If you're going to say your reasoning is nth term test, then your answer has to be diverge, right? Because that's all that it'll tell us. Are you guys doing okay on 13 and 15? What about 17? Is that geometric? It kind of looks like it, but it's not. That +1, there is no addition in geometric in your term. You with me? Did everybody see why that is not? Don't even try it. Is not geometric because that +1. So could you do the limit? How would you do the limit at infinity on that one? Wouldn't I have infinity over infinity? So what's the derivative of the top? What's the derivative of the bottom? Does that simplify? 2 to the n over 2 to the n plus 1?
2 times 2 to the n.
Yeah, isn't this like a... That just equals what? 1/2, which is not 0. And if the limit is not 0, it's what? Diverge. So that was a diverge by the nth term test.
So there's no addition or subtraction.
In the geometric. It's just an a times an r to the n for a geometric. So then 37 and 40, I mean, we're here. You might as well go for it and do the sum of those, right? 40 is, as n goes from 0 to infinity, it's a 3 times -6/7 to the n. for 37 and 40. Notice both of those start at 0. I hate that the textbook doesn't give you any of the thinking ones, but I'll bring us a whole list of some for us to try next time, okay? Where it has the weird stuff. Are we doing okay on 37 and 40? Just using the formula straight up. I circled the ones that we had narrowed it down to on this page. I think we have time to let you get these knocked out before we go to the next two tests, just to kind of help you narrow down a little. The good thing about today's is you only have two to choose from. It's either geometric or it's not, and if it's not, you're going to do nth term test, right? I like 69. This isn't 1 to the n, just 1. Substitute 2 for what? If you do the nth term test, it's going to equal 0, which is inconclusive, right? So that means you got to try a different test. Yeah, I mean, you would definitely try the nth term test, but since it equals 0, it doesn't tell you anything, right? It's only if it doesn't equal 0 that you know it's a diverge. If it does equal 0, you don't know what it is. You got to try something else.
If there wasn't a 1 in the numerator, would you be able to bring this n up as next one?
Well, like, give me an example. If was something else.
Like a different, like if it was 3 over 2.
Okay, so if it was like a 3,
over 2n.
you could, if this was a 3,
Yeah.
you could bring that 3 out here with the 4 and say 4 times 3 and then times 1 over. Yeah. Yeah. Somebody raise 69, y'all see what you need to see in 69.
71 be considered one of the ones with
Say that again, would what?
would 71 be one of the ones with coefficients, or how?
Well, 71 is not geometric, because it is not something, you have an n, but the exponent is not n, right? Geometric has to have an exponent of n. So it's not geometric, I have to try nth term test.
Okay.
So I would get infinity over infinity. Oh, so maybe I'll try a L'Hopital. Are you talking about on 71? Did you say yeah? So you did L'Hopital, right? So you got 1 over n, which is just n. And then substitute infinity. Uh-huh. For 71? Like saying it's geometric? What do you mean? Oh, for nth term test? Are you saying can you cross out the n's? I'm not sure what you're saying. So you're saying when you do this limit, right? Because nth term test says we're doing the limit. Okay, now tell me what are you gonna do? 1 over ln of n? Is that what you said? So you mean just like cancel that out?
No.
So here's how you have to approach it. What's the first thing you always try?
I know how to do it that way.
Okay. You have to start there. You have to start with your substitution. I mean, unless it's a polynomial over a polynomial, but that's not what this is.
Miss Napier, could you quickly talk about class 2?
Does 73 look familiar at all from last time? From the last class? Number 6 on page 271. Number 6 on page 271. Look at that one. Remember what we said about that limit? Number 6 on page 271. And think about that one when you try to do number 73. And even though you don't know what k is, you know it's a constant. So e to the k is a constant. So that limit equals whatever e to the k is, which is not 0.
So, what do we say that's by some sort of test or substitution?
Well, it was the nth term test. Because whenever you're doing your substitution, you're doing the limit. That's the nth term test. Yeah. Are you okay on 73?
Yes.
75. Hey, is that geometric? No. Geometric doesn't have trig functions. So you must try the nth term test. So the first thing you do is substitute in infinity. What's the arctangent of infinity? Pi over 2. Right? Because the tangent goes to infinity at pi over 2, which is not 0. All right. Okay. Ask me. You have a question, Jake?
On 73.
Is that the 1 plus k over n one? Okay, so it's obviously not geometric. So we have to do the so we're going to do the limit, right? As n approaches infinity. If you do the limit as n approaches infinity, That number 6 that I pointed you to on page whatever, where we said that limit always comes out to be e to the whatever that numerator was. So the limit there is e to the k. Now I don't know what k is, but I know it's a constant. So e to the k is definitely not 0. So the limit is not 0, which means it's a diverge. And that's all we needed on that, is to know the limit was not 0.
I'm getting confused between not 0 and what it means and 0 and what it means about not 6.
Yeah, but we won't go back to that. So you'll start getting used to this and you'll forget that one. And then right before we take the AP exam and this test, I'll say, hey, you guys, remember how we always did this? But you actually had that one little sequence thing. There might be a sequence question on the AP. I mean, might. You know how I said this is like overall this chapter is 25%? There, one of those, let's say, 10 questions might be a sequence. It might not be. Depends on the year. Okay, ready? 2 more tests. So far, here's what I'm hoping. I'm hoping you can look at it and have an idea if you think it's geometric. And then if it's not, you're definitely going with the nth term test, right? So far. Question? The arctan one? Okay, it's definitely not geometric. So we do the limit as n approaches infinity. If you plug in infinity, arctangent of infinity is, when does tangent go to pi over 2? Think about the graph. I'm sorry, I mean, I said it backwards. When does tangent go to infinity?
Pi over 2.
Isn't that at pi over 2?
The tangent graph is like flipped over the y plus x-axis to make the parent function. But then if
We're not graphing arctangent. I'm saying that I know that the tangent graph has an asymptote at pi over 2, right? So I could say tangent of pi over 2 equals infinity. That's the same as saying the arctangent of infinity equals pi over 2.
what I was confused about was just like, since like the tan function has like this repeating, right?
Yeah.
And then if arctangent would flip it over y plus x with arctangent, wouldn't the arctangent graph that's like pi over 2, the beneath the one that goes through the origin approaches it?
Yeah, but you don't look at multiple arctangents. Arctangent is only defined on one of the intervals. So that's why. Yeah. Okay? By definition, all of the inverse trig functions are only defined as one of the intervals, not the whole thing. Okay. So we have 2 more tests. So let's say it's not geometric. You do a real quick try the limit and it equals 0, so it's inconclusive, right? So far we have a plan, right? Quick check on geometric. Try nth term test. If it's inconclusive, if it equals 0, it's inconclusive. Now we have 2 more tests we're going to try. Okay? Integral test. You knew we weren't done, right, with integrals? Okay, when do I use the integral test? Well, the integral test works well on terms that are easily integrated. I mean, we don't integrate everything. There are some things that are like, oh my gosh, I don't know, right? But there are some things that I can easily integrate. So that's kind of a candidate for you might be like, nothing was easily integrated for me. Well, okay. I don't know what to tell you then. All right. Conditions for this test. Your terms have to be positive, so it doesn't work on negative terms. If you think of that term, like n over n plus 1 or whatever, if you think of that as a function, it has to be continuous. And the terms have to be decreasing. And I should say decreasing in magnitude, but since they're all positive, it doesn't matter. And here's the thing, though. We say that because really those are conditions, but usually we kind of ignore that. The only time I would pay attention is if I had a question that said, could you use the integral test? Because then that makes me think, hey, I wonder if there's some trick why I couldn't. Do you know what I'm saying? And so you would look and say, hey, are all these terms positive? Would this be a continuous function? And then how do I know if they're decreasing? Just try n equals 1, n equals 2, n equals 3, and see if the terms are going down. Okay, but again, otherwise we're kind of like, yeah, but whatever. I'm going to try integral test. Okay, so here's how the integral test works. Whatever that a sub n formula is, we think of it as a function of x. Okay, we think of it as a function of x. So basically, we just integrate from 1 to infinity, or whatever, let me back up here, whatever this is right here, from this to infinity, this is what we're integrating. It's basically we kind of put an integral sign in place of the sigma sign. And we think of it as in terms of x instead of n, just because that's what we're used to integrating. Okay? And so if that integral, well, let me say, either if the integral converges, then that means that the series converges. Remember when we did these integrals, we said, hey, does it converge or diverge? Remember that? So if the integral converges, then that means the series converges. So that takes us back to what made the integral converge? Do you remember? If we got an answer. If the integral gave us a nice, neat, gave us a nice, concrete, finite answer, constant, we said it converged. So what we could say is, if the integral equals a specific constant, then we know that the series converges. And if the integral doesn't equal a constant, meaning if it was infinite, then we say it diverges. Okay? So it's kind of like, hey, the limit didn't work, tried to integrate it. You know, what can we possibly do to this term? Can we do the limit of it? No. Well, how about can I integrate it? Now, something I need to point out, however, just because the integral converges to a specific constant does not mean the series converges to the same constant. So if my integral equals 3, that doesn't mean that the series equals 3. It just means that the series converges. I don't know what it converges to. Okay? Just because integral means area, just because the amount of area is a certain number, that doesn't mean that's the number you get when you add up the individual terms. Okay? So, here's how I would approach my first example. When I look at this, I wouldn't say, oh, I'm going to do the integral test. I would say, hey, is it geometric? Quickly, I say, no. Then I'd say, what about the nth term test? What's the nth term test going to equal? Compare the degree of the top and the bottom. Isn't it 0? Oh, it's inconclusive, so I can't use that, right? And then you'd say, well, what can I do? Can I integrate it, maybe? Now, normally I would say, hey, is it positive, continuous, and decreasing? But just to do a quick look, n over n squared plus 1, if n starts at 1 and gets higher, it's definitely positive, right? Not a problem. Is it continuous? Well, will the denominator ever be 0? No. Are they decreasing? Just put in a couple terms. If n equals 1, isn't it 1 over 2? If n equals 2, isn't it 2 over 5? Is 2/5 less than 1/2? They're decreasing. But again, we don't usually pay much attention to that. Okay? Can we integrate it? And so we think of it as x's. Remember I said just replace the sigma sign with an integral. Think of it as x's. I see a nod. How would I integrate that? Don't I want to think about it? Could it be a u prime over u? What would I need in order for it to be a u prime over u? Come back. Wouldn't I need a 2 up there? Oh, but what do I have to do to make up for that? Pull the 1/2 out in front. So when I integrate, I'm going to get 1/2 what? Natural log of x squared plus 1. Only go as far as you have to. If I plug in infinity, what's the natural log of infinity? Infinity. Done. It equals infinity. So if it equals infinity, is it converge or diverge? It's a diverge. Okay? So again, you go through your quick thought process. Is it geometric? No. Could I do the limit? Well, I could do the limit, but wouldn't it be 0? Doesn't work. I wonder if I can integrate this. Someone wow and impress me. What? Oh, Kathy. I'm wowed and impressed. Did you all see it? They all, in their mind, Kathy, they're being like, oh, thank you, Kathy. I see it now. Arctangent, remember 1 over x squared plus 1? What's wrong? Question?
Never mind.
Ask me.
No, I was confused how much problem we were doing.
Oh,
and I was like,
sorry.
oh, geez.
Did I skip one or something?
No.
Okay.
you're fine.
And so, Matthew, what's the arctangent of infinity? Pi over 2. And what's the arctangent of 1, you guys? When does tangent equal 1? Pi over what? 4. What's pi over 2 minus pi over 4? Pi over 4. And since it equals a finite constant, I would say it's a converge. Notice on these, we're not asking you to find the sum. I don't know how to find the sum. They're not going to ask you. They're just going to ask you on this one to converge or diverge. Okay? All right. P-series, my favorite. I don't know. I do love geometric. P-series is up there. Geometric might be in first place and then P-series. P-series is very easy to tell converge or diverge. Of course, so is geometric, if it's in the right form. Okay, P-series, if you have like a 1 over n to the P, so 1 over n to the first, 1 over n squared, 1 over n cubed. No, don't think of. No, n is what changes, right? So like if n equals 1, what's my first term? What? What's 1 to the P? What's 1 to anything? 1. So what's my first term? 1. What's my next term? If n equals 2, I would have 1 over 2 to the P. And my next term is 1 over 3 to the P. So n is what's changing. P is staying the same. So what would this look like? It might be a 1 over n squared. It might be a 1 over n to the 1/2. It might be a 1 over n to the 54th, right? Basically, any power of n on the bottom is called a P-series. Any power of n on the bottom is a P-series. This is the one that will start to kind of blow things wide open, where we can really start to do some thinking here, okay? So, if P is greater than 1, then it's a converge. So 1 over n squared, converge. 1 over n cubed, converge. 1 over n to any power more than 1 is a converge. Because that means the terms are not only going to 0, but they're going to 0 fast enough that eventually you're not adding anything else on. Okay? But if n is between 0 and 1, I could say really less than 1. It's just that if it's a negative, if it's like 1 over n to the negative 2, isn't that the same as just n squared? Do you see what I'm saying? So that's why we just think about the P as either being more than 1 or like a fraction. So if P is like just a 1, or if P is a 1/2, if you have 1 over n or 1 over n to the 1/2, yeah, they're going to 0, but they're not going to 0 fast enough that you would have a finite sum. So basically, if that P is between 0 and 1, the series diverges. Notice the equal to part goes with the diverge. If it's just 1 over n, it's a diverge. And that's kind of our standard by which we judge all others. 1 over n. That's like the going to 0, but it's still a diverge. So think about how fast n increases compared to the numerator. If I have 1 over n, 1 is just a horizontal line at 1, right? And n is like a line right here. So think about how fast this increases compared to this. You're like, okay, how do I compare? Well, just look. It increases that much more. How much? That much. I don't know, that much. Okay? So think about the difference, but compare that to this. So here's 1, a flat line. Compare that to how fast a parabola increases. That's a lot more of an increase than this. It's more of an increase than these two were, a difference, right? And so anything this direction goes to 0 so much faster that you actually have a converge. Anything less, think about like 1 over n to the 1/2. What is n to the 1/2? Isn't that like a square root? Compare that to 1. Yeah, this increases faster, but not that much faster. Do you see that the difference in the increase here is not even as much as the difference in the increase here? So it's kind of like this is the standard by which I judge. Okay, this thinking is what's going to get us to where we're going to get to the end of this chapter, and you're not going to be able, you're not even going to need a test. You're going to look at every single one and say converge, diverge, just based on this concept. The hard part for you is going to be like, hey, I know it's a converge. What test would I have used? Because we're going to get to the point we don't need tests. We're going to be able to just look at it and know. That's what we're going to do. Okay, so let's keep going here. So, anybody into music in here? Anybody a music-y kind of person? Yes? No? Okay. If P equals 1, then the series, so 1 over n, okay, the series is called the harmonic series. This is related to music and like the vibration of notes kind of thing. We're not going there, but so 1 over n is called the harmonic series, and we know, is that a converge or a diverge? What did we just say? If P equals 1, so it's 1 over n, it is definitely a diverge. We know that. Get that in your brain. Never, ever, 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 never to forget it, and you won't after today. So how does that compare to 1 over 2n plus 3? Think about how 1 over n, how much of a difference. Yeah, what's the slope of the bottom? It's 2. You're like, well, that does increase faster, but it's still linear, okay? So if the denominator is still just linear, still a power of n, even if it's like being multiplied by 3, it doesn't change it enough. We call this a general harmonic. And I could go through a proof and show you why it's still going to be a converge. And if you want to write it, you can, but you don't have to. You could just kind of look, because from now on, you're not going to do it. You're just going to be like, oh, that's still a converge. So if I were going to integrate this, what would I think of it as? Isn't that like a u prime over u? Except I would need a 2. So you bring out a 1/2. And if you plug in infinity, you get infinity, which is a diverge, right? So it doesn't matter if it's a more involved n to the first. If it's just an n to the first down there, it's technically not called a P series because it has the extra stuff. But we can still just look at it and know, oh yeah, that's just like a 1 over n, that's a diverge. See how we're kind of starting to explode the rules into just thinking them out loud? Okay, so what about this one? 1 over square root of n? Is that a P series? Is it a power of n? P series, power. It's a power of n. What is it? N to the 1/2, so it's a diverge. Ooh, what about number 2? That's a good one. 1 over n to the what? Wouldn't that be to the 3/2 if you add your exponents? So is that a converge or a diverge? Converge. Okay. So we're starting to think through the whole difference in how fast the numerator increases compared to the denominator, right? So 1 over n, diverge. 1 over n squared, what? Converge. Is there anything between n and n squared? Think about this one. Okay. N times, I don't know what that graph looks like. No. But if I multiply n times the natural log of n, doesn't it seem like it's getting bigger than just n? If the denominator's, so it seems, but is it going to increase as much as like an n squared? Right? Do you see how we're kind of thinking about this? What's your speculation? You think it's going to be a converge, diverge? Give me a guess. You think it's a diverge? So you don't think it's enough to be like a 1 over n squared? Okay, so the way I would test it is I would do an integral test. Why? Because it's not a geometric. When I do the limit, I'm going to get 0. So I would try an integral test. It's not a P series. How would I do this integration? What would I let u equal? Yeah, when there's a log, we always let that be our u. So if u is natural log, your du So we're actually integrating what? Bless you. 1 over u. And if I integrate that, it just becomes isn't that just natural log of u? Oh, but wait a minute. Before I can plug in, don't I need to plug my u back in? So really, it's like the natural log of the natural log, right? No matter how you slice it, that's just going to be infinity, right? Who gets diverge? So even though we multiplied by natural log, it still wasn't quite as fast as like an n squared down there. All right. Let's,
So for these converse stuff, you don't need to find the sum.
no, they won't ask you for the sum of this because we don't know how to find the sum of this.
Sum would only be for
So far only for, actually, since we're not doing telescoping, it's the only one that they'll ask us for the sum of.
and certain geometry.
Pardon me?
It's only and certain
Right.
geometry.
Now, all right, take a look. Here's where we're going to start to think. I know this is on there. This is just us thinking. This is what we're going to gradually expand on each day, okay? Here's what I call, okay? So we're thinking about how fast the numerator and denominator increase. Okay, so let's determine, just looking up here, determine the convergence of each. So we know this one is a what? A diverge, right? Okay, and we just did this one and we said diverge, didn't we? Okay, what would you speculate on this one? Just thinking out loud, based on no rules, just how fast the denominator increases compared to, say, the 1 over n. Does natural log increase slower or faster than n? Remember how we compared earlier? Wasn't it slower? Remember how we're looking at the difference between the top and the bottom? Well, if natural log of n is slower, it's not as much of a difference as 1 over 1 and n, correct? So what's your guess? Way not fast enough. It's got to be a diverge, right? What about, don't go geometric. Forget, don't try to do geometric. Think about how fast 2 to the n increases compared to just n. Isn't it a lot faster? So based on that comparing, couldn't you like quickly and easily say that has got to be a converge without even thinking geometric? You with me? Because 2 to the n increases so much faster than just n. I mean, it's faster than an n squared or an n cubed or an n to the 5th, right? What about 1 over n squared? We know that one. I mean, we could say p series, but n squared is way faster than n, right? That's a converge. Converge. Come on, baby. Tell me. Okay. Shoot. I have so much. So if I give you all right. Right, you got like a scratch paper down at the bottom. Write down these equations. Oh, here we go. Actually, you don't need to write them down since I'm going to have it here. Okay, write them down. Weird stuff. You wish you could see what I see. Okay, write down n, just across, going across. Write down n, square root of n, e to the n, n squared, natural log of n factorial, and 2 to the n. Holy cow, all kinds of crazy stuff is going on. Okay? Can you put those in order from how fast they increase from slowest to fastest? Like, which one has to be the fastest? Factorial. That's the fastest, right? We'll put that on the far right. Which one's the slowest? Is it natural log or is it square root? Remember how we drew them up here? Which one was slower? Wasn't natural log slower than square root? Do you remember? We said square root Natural log, remember that? So you got natural log's the slowest. N factorial is the fastest. Where are the other ones going to fit, you guys? See if you can fill them in from low to high. Think you got it? There's my low and my high. Think you got them filled in where they belong between those? Did you put square root of n next? Then what? N, then what? N squared. Then what? To the n, and then e to the n. So if you know that, then that's going to help you with this whole common sense approach kind of thing. Now, when you do your homework, think tests. Think tests, because you have to come back and say which test it is. But this is what we're going to gradually kind of explore so that we can just kind of do them very quickly and easily by looking at them. Because if you know the answer, sometimes that helps you get to the test. Got the idea? Would you agree with this one? N over 2. You're like, oh, it's not a 1 on top. No, but think about how fast n increases. Linear, compare that to exponential. Is the difference in a linear and an exponential more than the difference between a constant and a linear? It definitely is. So your guess would be converge, even though right now we don't have a rule for that one. But based on how we're thinking these things out, my guess would be converge. What do you think if it were an n squared? Do you think that still exponential is enough more than a parabola that it would be a converge? Remember how earlier I said, what about compare exponential and n to the fifth? Remember that? An exponential is way more than a polynomial, so that eventually it would be a converge. What about this one? What's your guess? Converge, diverge? I mean, this is the fastest ever in the whole wide world, right? So it has to be, I mean, that's way, 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 way more than 1 over n. That has to be a converge, right? What about this? A factorial is way more than a linear, right? What about this? Exponential is pretty darn fast, right? N factorial is definitely faster. Is it enough faster? What's your guess? Yes. Yes. N factorial on the bottom. Doesn't matter what's on top unless it's another factorial. It's going to be a converge. But that's where we're kind of going. Okay? You all have the... Oh, that's not... You all have the numbers written on that page, right? The homework? Okay. Hello.
I'm in your book. I just needed 3 people.
Thank you for waiting.